There is a problem with the Big Bang, not the event itself, but what happened immediately after. For decades, our Standard Model of Cosmology was neat and tidy. We believed that after the universe began, there was a long, dark age. Gas slowly cooled, gravity gently pulled it together, and eventually, over hundreds of millions of years, the first small, dim stars flickered into existence. It was a logical timeline. It made sense, but it was wrong. When we launched the James Webb Space Telescope, we expected to see the toddler photos of the universe. We expected to see clumsy, forming blobs of gas. Instead, looking back to just 300 million years after the Big Bang, we found something that shouldn't be there. We found monsters, fully formed, massive, bright galaxies that looked far too mature for an infant universe. This discovery has triggered a crisis in astrophysics. It suggests that either our understanding of the universe's age is wrong, or the very laws of physics were different at the dawn of time. Today, we are going to look at exactly what the golden eye has found, from the impossible galaxies at the edge of time to the chemical blueprints of life in our own backyard, to understand why the universe is far stranger and far more crowded than we ever dared to imagine. The story begins with a single point of light, one that has traveled for 13.5 billion years to reach us. To understand why this specific light is rewriting history, you first have to understand what we were blind to before. For centuries, astronomy was limited by two great barriers: dust and expansion. The universe is filled with swirling cosmic dust that blocks visible light like a heavy curtain. Behind that curtain, the universe is expanding, stretching the light from the first stars until it shifts out of the visible spectrum entirely and into the infrared. We were effectively trying to read a book in a dark room while wearing sunglasses. We missed the first chapters of existence. The James Webb Space Telescope changed the game because it doesn't just look at the dust, it looks through it. Its infrared detectors are designed to capture that stretched ancient light. And almost immediately, it pointed its mirrors at a region of space known as JWST, the JWST Advanced Deep Extragalactic Survey. There, it found a galaxy now known as JWST GSZ 14-0. The light from this galaxy comes from a time only 300 million years after the Big Bang. According to every simulation we have, a galaxy from this era should be tiny. It should be a messy, low-mass cluster of gas just beginning to spark. But JWST Z14 is huge. It is hundreds of millions of times the mass of our sun. It is bright, structured, and inexplicably mature. Finding a galaxy this advanced so early in the timeline is like walking into a nursery and finding a teenager sitting in a crib. It defies the growth rate of the universe as we understand it. It implies that stars didn't just trickle into existence. They burst onto the scene with a speed and efficiency that our current physics cannot explain. So if the standard model is broken, what replaces it? To solve that mystery, we have to look at how stars are born. We have to look at the process of creation itself, which Webb has revealed is far more violent than we thought. Take the pillars of creation. You've likely seen the famous Hubble image, statuesque columns of gas, silent and majestic. Webb looked at the same pillars, but it stripped away the dust. In the infrared, those silent pillars became transparent, revealing the chaos inside. Webb spotted hundreds of newborn stars that were previously invisible. These aren't just sitting there, they are screaming into existence. They are launching energetic jets of hydrogen, creating shock waves that ripple through the cloud. This isn't a slow gravitational collapse, it's an explosion of activity. We see this even more clearly in a region called Sharpless 2-284 on the outskirts of our own Milky Way. There, Webb found a protostar 10 times the mass of the sun. This isn't just a star forming, it's a star fighting for space. It is blasting out jets of superheated gas in opposite directions, a bipolar outflow spanning 8 light years. That is double the distance from our sun to Alpha Centauri. These jets act like cosmic snowplows, clearing out the gas to stop the star from choking. This is a crucial clue. This star is forming in a region with very few heavy elements, conditions that mimic the early universe. It proves that massive stars can form aggressively and quickly, even in pristine environments. This helps explain how the early universe could light up so fast, but it doesn't explain everything. It explains the stars, but it doesn't explain the life, because the universe isn't just building stars, it's building the ingredients for biology. And Webb has found that these ingredients are not rare accidents. They are everywhere. Let's pull back from the edge of the universe to our own own neighborhood. Webb recently turned its gaze to a comet named 3I/Atlas. This wasn't a standard rock, it was a messenger from another star system. When Webb analyzed the light reflecting off this comet, it opened a Pandora's box. The comet was unusually rich in carbon dioxide and water vapor. It formed in the freezing outskirts of a distant planetary disk, yet it carries the exact same chemical signature as the comets in our own solar system. This is profound. It means the recipe for our solar system, the water and carbon that make up you and me, is not unique. The galaxy is cooking with the same ingredients everywhere. We see this confirmed even closer to home in the Alpha Centauri system, our nearest stellar neighbor. For decades, the glare of the two main stars made it impossible to see if anything was orbiting them. But Webb used a device called a coronagraph to block that glare, like using your hand to block the sun. So you can see a plane in the sky. It spotted a candidate, a gas giant roughly the mass of Saturn, orbiting Alpha Centauri A. While the gas giant isn't habitable, its existence proves that our nearest neighbor has a planetary system. And if there is a Saturn there, there could be an Earth there hidden in the glare. But the most striking discovery regarding the origins of life comes from a young system called CT-CHA-b. Here, Webb didn't just see a planet, it saw a moon factory. It detected a disk of dust swirling around a young Jupiter-sized world. But unlike the water-rich disk of its host star, this moon-forming disk was packed with carbon, acetylene, and benzene. These are complex organic molecules. We are seeing in real time the assembly of a chemical reactor in deep space. It tells us that carbon, the backbone of life, is processed and concentrated during the formation of moons. The universe seems hardwired to produce these complex chemicals. So we have a universe that builds stars violently and quickly. We have a universe that is saturated with the chemical building blocks of life. But we still have that one nagging problem. The monster in the dark. The impossible galaxy at the dawn of time. How did JEDA's GSZ140 get so big so fast? There is a theory that has moved from the fringes of science to the forefront of the conversation. Because of this data, it's called the dark star theory. When we look at that ancient galaxy, we assume the light is coming from millions of regular stars powered by nuclear fusion. But what if it isn't? In the very early universe, dark matter was much denser than it is today. The theory proposes that the first stars weren't powered by fusing hydrogen, but by the annihilation of dark matter particles inside them. These wouldn't be stars as we know them. They would be giants, millions of times the mass of our sun, but puffy and cool. A single dark star could be as bright as an entire galaxy of normal stars. This would solve the mystery. If JWST isn't a galaxy of millions of stars, but a cluster of a few dozen supermassive dark stars, the math works. We don't need to break the laws of physics or change the age of the universe. We just need to accept that the first lights to switch on in the cosmos were powered by the most mysterious substance in existence. Webb hasn't just given us sharper images. It has given us a new reality. It has shown us that Neptune's rings glow with ethereal dust we've never seen. It has shown us the phantom galaxy, NGC 628, where spiral arms look like skeletal ribs of glowing gas. But most importantly, it has brought us to the edge of our understanding. We used to think the story of the universe was a slow, gradual climb from darkness to light. Now we know it was a sudden, explosive, and complex eruption of structure and chemistry. The universe wasted no time. It got to work immediately, building the massive structures and organic molecules that would eventually lead to us. We are still only a few years into this mission. We have 20 years of fuel left. If we have already broken the Standard Model of Cosmology in the first few years, what will we find in the next decade? The veil has been lifted, the golden eye is open, and the universe is finally revealing its secrets. If you want to stay updated as we unravel more of these mysteries, make sure you are subscribed. The universe is getting stranger by the day, and you won't want to miss what comes next. Thanks for watching.